Cube games. They're cool, right? You know what's cooler? More cube games. We just need to make one more. One cube game to rule them all. Just one more, and I promise this will be the last one. Lies. So many lies. We'll never stop making cube games. And that's what I'm here to do. I'm here to never stop making cube games. I think I'm contributing to the problem. The first thing you've got to do is choose a game engine. We've got plenty of options. Unreal Engine, Unity, Godot. Okay, maybe just 3 options. But 3 options that all have something in common. They're lame. I don't want to make a lame game in a lame engine. If I'm going to make a cube game to rule them all, I'm going to need a good game in a good engine. If we want to make a non-lame game in a non-lame engine, we're going to have to make our own engine. It's the only option. Which means we've got to choose a programming language. You can pretty much do this in any language, so I'm going to do it in C. I don't have much reason for choosing C over C++. I just like how you code in it more. Plus, Linus Torvalds said it was better, so as an Arch Linux zealot, I'm going to have to go with C. Now we need a graphics API. We've got a few to choose from. There's OpenGL, which is easy to use. Pretty much every GPU supports it, but it's only made for single-core CPUs, and it's old and at times clunky to code in. We've got DirectX, which is what dorks use. No further explanation. And then we have Vulkan, which is fast, low level, very modern, but quite complex. I'll go with OpenGL for now, for simplicity, but I may switch to Vulkan later for faster loading times and slightly higher frame rates. And I'm going to use CMake for the build system because it's cross-platform and very flexible. Now you might be thinking that I just said I was using C, and .cpp files are for C++ files. Well, I like operator overloads for my maths functions. So get off my case, man. So I don't have any footage from the start of the project. We're going to have to make do with the first time all the voxels were working. So we've got cubes, as you can see. Pretty cool. Looking good. Okay. What's that? Give me 1 sec. There we go. Now this is running at about 6,000 frames per second, but that means we can only have 100 of these chunks, which is not enough. So we're going to have to add levels of detail, which mean objects far away from the camera only contain rough details. How we will implement this here is by making larger cubes the further they are away from the camera. So if we could just close our eyes and all pray to Jangus. Boom! See guys? Jangus is real. Now they look pretty good, but there are some seams between them due to the change in voxel size. So I think we'll just draw every face in between the chunks and ignore the performance hit for now. Now you can't see this because I've started the recording once all the chunks were generated, but the mesh generation is a bit slow due to a pretty bad algorithm. So I'm going to follow this ancient saying, if you can't do it right, do it on the GPU. Sun Tzu. A bit of infuriating OpenGL code, and some different terrain generation, and boo shakalaka, it works. Now that the mesh generation is a lot faster, we should work on the voxel generation. By, drumroll please, breaking everything and making it slower. It does give a pretty cool fractally design, but that isn't a very good excuse for it not working. Now we could fix this issue now, if we really wanted to, but that's the problem. I don't want to, so I'm going to do something else. Now I lied to you when I told you about that ancient saying. There's actually another part to it. Here's the full saying. If you can't do it right, do it on the GPU. If you can't do it on the GPU, do it on another thread. Here we go. Voxel generation is still not working, but that's fine. We can... Okay, it just crashed. Look at that, I've changed the background color. It also doesn't crash, but let's keep our priorities straight. Now it's starting to look pretty good. Got a lot of voxels, you can see pretty far, but on the inside, it's not great. Literally. Have a look. This was a pretty complicated fix, because the new mesh generation is quite complicated. Here's the result. Now in this footage you can see that when you move very fast the terrain struggles to keep up, but a lot of that is due to the priority system. the terrain prioritizes really far away chunks before the central ones. And that sounds really silly, but the reason is so that there aren't any holes in the world. Right now I'm prioritizing no holes being in the world rather than it loading in fast. But I think I'll have that fixed done in the next devlog. Now if you can look past the bad load priority, the game runs pretty well. At its peak, it's used 200 megabytes of RAM and 100 megabytes of VRAM, and the chunks, which are 256 cubed voxels, take on average less than 4 milliseconds to load, and the longest any chunk has taken to load is 70 milliseconds. I don't want to talk about the rendering performance though, because as you can see it's quite abysmal, and it's running on a pretty high-end GPU, a 6900 XT, which has rasterization performance pretty similar to a 3090. Luckily, occlusion culling and frosting culling work pretty well with voxel games, so that should drastically cut down the rendering time. Now all of this is running on my Ryzen 9 7900, which is a very good CPU that has 24 threads. I'd like the game to run on any Ryzen CPU, or a pretty good Intel 7th gen. And then for the GPU, I'd like it to run on a 1050 Ti or an RX 580. The footage that I'm showing you now is on what would be medium to low settings of the game, running on 2 threads of my CPU, and I'm hoping that 2 threads of my CPU will be worse than all the threads of a pretty old CPU. I'm not concerned with the GPU performance right now, because it'll be pretty easy to just add very low settings that just have the voxel color, a bit of ambient occlusion, and some shadows. This is some footage of the game running at what will probably be max settings, using 8 threads of my CPU, with a slightly better priority system, but by no means good. That's it for this devlog. In the next one I'd like to add multicolored voxels, better multi-threading, a better priority system for generating chunks, and a much more interesting terrain. If you like this video, I've been Ziggy Harding. Otherwise, this was all AI, so don't blame someone for something that they didn't make.